Superheavy is SpaceX's reusable booster rocket for the Starship system. It will be the first stage of the Starship system and carry the second stage to orbit. After it has done its job, Superheavy is supposed to fall back to Earth and perform a controlled landing. Initially, people thought this landing would be similar to SpaceX's other reusable booster rocket platforms. Yes, we are talking about Falcon 9. The Falcon 9 uses retro-propulsive maneuvers to slow down and land upright, but for Superheavy and the Starship system, SpaceX has other ideas. This video will go through SpaceX's insane new plans to catch the Superheavy on landing. The Orbital Integration Tower. At the heart of this plan to catch the Superheavy is SpaceX's new Orbital Integration Tower. You can see this mammoth of a tower sitting at the center of Starbase, SpaceX's Starship testing facility in Boca Chica, Texas. A robotic arm structure will be attached that will catch the rocket once it comes to land. But the Orbital Integration Tower has many other functions as well. The Orbital Integration Tower will also be used to place the Starship system on the launchpad and vice versa. Once a Superheavy booster lands on the platform, the Orbital Integration Tower can lift it up and place it off the launchpad for servicing. The construction of the Orbital Integration Tower was first announced in March 2021. SpaceX filed with the Federal Aviation Administration to build a 469 feet tall steel truss structure with a 10-foot-long lightning arm. According to the filings submitted by SpaceX to the FAA, this tower would be used to lift Starship and Superheavy onto the launch mount. It also further mentions that this tower will be used to catch the Superheavy upon its return to Earth. The tower was assembled by using prefabricated segments. These segments were made on a nearby site. The sections were prefabricated about 2 miles west of the launch area. The concrete base and first steelwork of the Orbital Integration Tower appear to be approximately about 105 feet tall, while each prefabricated segment is around 60 feet tall. SpaceX is also adding a robotic arm mechanism to the Orbital Integration Tower. Elon Musk calls the mechanism Mechazilla, a pop culture reference to the infamous Japanese folklore monster Godzilla. The tower has 6 vertical rails running along most of its length. These tracks or rails will support some sort of elevator-like carriage meant to hang on to the tower's exterior. That carriage is outfitted with large arms capable of catching, stabilizing, and fueling Starship. It is not clear if SpaceX will have this system ready before the SN20 launch, but it seems unlikely since there has been no information released by SpaceX or Elon Musk on the subject. We have seen each section slowly moved in place throughout the past few months and then fitted as the tower rose to new heights. Last month, SpaceX had been hard at work completing the 9th and final section of the launch tower, which is believed to be the roof. Overall, it took 9 sections to reach the 440-foot-tall height the tower is standing at right now. How does the catching mechanism work? The Superheavy booster is the first stage of the overall Starship system. Once the Starship reaches orbit, it will detach the first stage, that is Superheavy, and fire up its own 6 Raptor engines to continue the journey. The Superheavy performs a controlled deorbiting maneuver and free falls towards the Earth. During the freefall, Superheavy will be using massive grid fins to help it steer. Superheavy has 4 of these fins on its body, 2 pairs that are 60 degrees apart from each other. These are huge fins that weigh about 3 tons each. Falcon 9 has similar grid fins on its body as well, but unlike the grid fins on the Falcon 9, these ones are huge in size and weight. The grid fins on the Superheavy also don't fold in like the ones on the Falcon 9 do. These grid fins control about their axis and help Superheavy steer during freefall. This allows Starship to properly orient its landing. Another difference between Falcon 9's grid fins and Superheavy's grid fins is that the grid fins on the Superheavy don't fold inwards. They stay erected outwards throughout the journey. As the Superheavy approaches the landing pad and the Orbital Integration Tower, it will perform final adjustments in its approach to line up correctly with the Orbital Integration Tower. Then, the Superheavy fires its engines for a retro-propulsive landing to slow down and deaccelerate its approach. Since the Superheavy has many Raptor engines, it can reduce its thrust-to-weight ratio around 1, which means that this will allow the Superheavy to hover and adequately orient itself. When the Superheavy does that, robotic arms, the Mechazilla, will extend from the Orbital Integration Tower assembly and essentially catch the tower via its grid fins. Now that the Superheavy is caught, the Orbital Integration Tower can gently place it down. This ensures that the main body doesn't feel the impact of the landing. Grid fins themselves are designed to be strong and structurally sound, so they can take the impact from the landing force. After the rocket is caught by the giant arms, it will gently be put down on the refueling platform. The Superheavy will then be inspected for any significant damage. Once refueled, the Superheavy is ready for the next launch, and will be placed back on the launch pad and then stacked with a new second-stage Starship. Think of the Superheavy in this case as a sort of elevator, taking starships up into orbit and coming back to take the next Starship. Why the need to catch the Starship? The main reasoning behind this unconventional way to land a reusable rocket is that this way, less stress will be put on the Superheavy each trip. If SpaceX manages to perform a landing without using landing legs, then that would mean any stress or forces associated with the landing won't be directly felt by the legs and the rocket structure itself. And for a rocket that needs to be reused a lot, the less structural stress it goes through, the better. That means less servicing and maintenance of parts going through load cycles in each landing. There is another advantage of not using landing legs. If the Superheavy is being caught, there is no need to have landing legs at the bottom. This means this unnecessary weight can be removed from the Starship. Starship's landing gear amounts to about 10% of its total weight. In theory, if SpaceX can make landings work without a need for landing gear, that would mean more payloads could be transported per launch, since extra weight has been stripped from the rocket structure. Elon Musk had precisely this in mind when he announced his plans to catch the Superheavy. In a tweet, he explained, "Saves mass and cost of legs and enables immediate repositioning of booster onto launch mount, ready to refly in under an hour." It seems like removing landing legs seems like a win-win situation for SpaceX. Why is the FAA not happy with Orbital Integration Tower? But not everyone is as excited about SpaceX catching orbital rockets with giant robots as we all are. The Federal Aviation Administration is publicly critical of the launch tower. The US aviation regulator has warned SpaceX that they still have not completed their environmental review of the newly constructed tower. In fact, they even have hinted that they could take the tower down if it was necessary for safety or environmental concerns. Everyone thought that the 400-foot tower was built with the blessings of the FAA. But later that month, FAA published a letter laying out their concerns about the launch tower. Excerpts from the letter read, "May complicate the ongoing environmental review process for the Starship/Superheavy launch vehicle program. The company is building the tower at its own risk. It is possible that changes would have to be made at the launch site, including the integration towers to mitigate significant impacts. It is possible that FAA could forcefully take down the tower in the future if they think it is a safety or environmental hazard. Even though the FAA's environmental concerns have been public for a while, SpaceX has been buzzing with activity the past few months, especially now since SpaceX is getting ready for the first ever flight test of the Superheavy. This test won't involve catching the Superheavy though. The system isn't ready yet. The SN20 Starship test plans to drop the Superheavy boosters in the ocean instead. But the future prospect of a giant rocket being caught by robot towers does sound intriguing, to say the least.